In the summer of 2018, I worked with two undergraduate students to develop a cluster based on the recently introduced Raspberry Pi 3 using a 64-bit operating system. At the time, there were few experimental 64-bit OSs available, so this was something of a challenge. Today, there are multiple supported choices available. Brett Trias assembled the cluster using a 3D printer to fabricate housing pieces from a design by Suzanne Matthews. He designed and added a couple of layers to hold the power supply and the Ethernet switch. By the end of the project, he was able to run a password cracking program on the cluster using a 64-bit version of the Gen 2 Linux operating system. Brett did a poster presentation of his work. We called this cluster TANGA. There ain't no good acronyms. The next summer, I refined the cluster packaging using a commercially available cluster housing that costs around $20 and is more compact than the original 3D printed casing. I added a 2-layer tray to hold the switch and power supply. This cluster, TANGA 1, has been used in an experimental parallel programming course. This is a TANGA 1 Raspberry Pi cluster. It consists of 3 main parts. The cluster itself is a commercial frame holding 4 Raspberry Pis. In this case, as we can see from the Ethernet ports on the left, they are Raspberry Pi 3s. A mix of 3s and 4s would be possible. This case costs around $20. It includes a separate fan for each Raspberry Pi. In addition to the Raspberry Pi, we need a power supply. This is a USB 6-port power supply. And we have an Ethernet switch. This one happens to be a TP-Link 5-port Ethernet switch. Some Ethernet switches can themselves be powered from the USB power supply. However, this one will not power from 5-volt USB supply and needs its own power outlet. The switch itself is actually encapsulated in a case that was 3D printed. This one is screwed and glued together so it won't come apart. But here's another one. This is the base of the case. The switch itself goes in here, and the dimensions can be adjusted to accommodate a particular brand of switch. On top of this goes the top piece. As you can see, you can make them in whatever color appeals to you. It has, it's slightly backwards. This is an early model. It has a notch in the front, but not in the back. Newer designs have notches at both ends for more convenience. The USB power supply goes in there. The Raspberry Pi cluster goes in there. And you have a nice, neat package. USB connectors power the device. The Ethernet connectors from the switch connect each node to the others. And because my design requires 2 separate power supplies, I have gotten a 2-headed extension cord so that I can plug both power supplies into this device and then plug it into a single outlet. Finally, this summer I devoted some research funds to a more complete cluster package, the Piko Cluster Kit. These kits include a purpose-built Ethernet switch and power supply mounted inside a plexiglass housing with either 3, 5, or 8 Raspberry Pis. This 3-board unit holds the Raspberry Pi 3B or 3B Plus. It is a nicely compact package, but does not include any fan. Under heavy usage, this might be a concern. Here is a 3-board unit for the Raspberry Pi 4B. The Ethernet switch has been moved to the other side of the housing since the Pi 4 moved its Ethernet port. Also, since the Pi 4 consumes more power and generates more heat, it includes a heavier duty power supply and a fan. The fan was rather noisy. I replaced it with a quieter aftermarket fan. A power switch is a nice addition to this housing. One trade-off is that only one of the Raspberry Pi boards in these cases can be connected to a monitor. The others are expected to operate headless.